Okay, welcome everyone to Cloud Data Driven online user group meeting. As you already know, our agenda for today is query tuning internal for the advanced SQL developers. Who am I? I am Jean-Joseph, currently working as a data engineer. I'm located in New Jersey, originally from Haiti. What are the rules, right? You guys are free to comment, but do it with respect. There must be no offensive comments. I have your video turned off. And also, you guys, if you want to ask a question, raise your hand and I will do the necessary for you. So you guys are free to connect with us and also visit our community data for latest update like datasaturdays.com and SQLsaturdays.com. Also, don't forget to register for future data-driven summit. We already have a tons of people save their spot, and we would love you to be part of this as well. Today's presentation is, we have Kevin. Kevin, by the way, it is an honor to have you here. You may not know that, but the thing is your content, your blogs, your video webinars helped me so much, especially when I just migrated to United States. English was my second language. So that's when it was a little bit tough. I had to work a little bit hard and then do a lot of research. You are one of my top favorite speakers.
Well, thank you.
Yeah, you're welcome. The topic is query tuning internal for the advanced SQL DBA. As you guys know, who is Kevin? Kevin is a head gig, MVP, blogger, speaker, author, and he's a database expert. He's gonna tell you more about himself. If you guys haven't saved your spot for migrating a data capture solutions with event, herbs, and stream analytic, I would highly suggest you to do that. And then the next one, it's gonna be on financial modeling with Power BI. Please do reserve your spot. And then if you wanna present any session, feel free to email me at jane.joseph@bigdatadriven.org. Kevin, thank you so much. It is an honor to have you here again. Thank you all for tuning. The floor is all yours. Feel free to share your screen and start with your presentation.
Thank you. And also, it's really great to see a lot of friends online. So Thomas, Deepti, Anders, quite a few friends here. And so, gosh, folks, I'm just thrilled that you decided to carve out some time and spend it with me today. Hopefully, you will learn quite a bit today. Some of the knowledge might not be terribly useful, but I think a lot of it will be at the end of the day. And so I'd love to hear your feedback. I also will, after this session, I'm writing a blog post, and so I will put the slides and scripts on that blog post as well, if you'd like to download them. A lot of people enjoy these scripts because I get into the 400 level, if you will. I get into the deeper stuff pretty quickly, and so a lot of people enjoy that because there's not a lot to be seen of that type. So yes, long-term database person. I started my career in the mid-'80s. I worked on a big Oracle project developing the air and watering recycling system that is in the International Space Station right now. That's how I got my start. And over the years, I've been blessed in my career to be working at some of the biggest and most interesting kind of cutting edge technologies. And so in the early 90s, before SQL Server was even a Windows product, I started to use SQL Server as well as Oracle. And I'd been writing books since the early 90s too. And so I've written 11 books over the year. My best known is SQL in a Nutshell. Jean, if you would like, at the end of our session today, we can give away one or two of that book in an ebook format. And it's a $50 book or so. So it's a nice little prize.
Thank you so much.
Good. Okay, great. And also, let me go back one here. Everywhere on social media, I'm at KE Kline. You can also reach me at kevin.kline@solarwinds.com and at kekline@outlook.com. So I try to be as consistent as I could on that topic. Now, what are we going to talk about today? All right. Well, so the title is Advanced Query, Query Tuning Internals for the Advanced SQL Server Developer. So what I'm going to do is I'm going to take you into a lot of code demos, and I'm going to show you things that maybe you haven't really thought about very much that can really improve your coding in special cases. Now, I'm not a big advocate for doing this for every query that you have to write, because a lot of queries are fine when they perform mediocre, just in the middle of the pack, because they're not doing that much activity. However, every now and then you're doing massive queries that are just huge in all that they do. And so it's at times like that, when you have a very large query, that you need to know more, and you need to do more than just the standard sort of query tuning that you might do in normal circumstances. So let's start with that. Let's start with normal circumstances. What does SQL Server do to create an execution plan? And why is the execution plan so important? Well, if you are a query tuner, the execution plan is essential. This is, I guess you could say, there's many useful analogies. I like to use the analogy of if you've ever played a video game where a character has to move across a screen and there's an impediment, maybe a little mountain in the middle of the screen, well, they have to go around that. That's called a pathing algorithm. And in a way, a SQL Server execution plan, or in fact, an execution plan for any database platform, Oracle calls theirs explain plan. You have to have a pathing algorithm, and they all use this this approach called cost-based optimization. So everything that SQL Server does to make your query perform well is based on how much it costs to do those particular operations. And the way it generates an execution plan, I have other sessions that go into a lot of detail about that, but the way it does creating an execution plan is it takes 3 domains of knowledge. And let me also take a quick step to the side and mention, if you don't know much about execution plans, don't know where to start, I'll take a minute and show you one, but there's a pretty good chance that this is going to be above your head. So it might be too much at this stage. You need to learn about execution plans first, because that's the fundamental building block for being a good query tuning SQL Server person. Okay, so stepping back onto the path now, SQL Server uses 3 domains of information in order to create an execution plan. The first is metadata. And many of us know of metadata as indexes and the statistics of those indexes, and also statistics that SQL Server might collect on its own. It has a feature called auto update statistics. And then it also has some other stuff that even deeper than statistics called histograms, which tells SQL Server across 250 some odd buckets where the most data is on a given index. So that's one domain, metadata. The next domain are specific, a short list of Windows Server and SQL Server settings. In particular, we're talking about the Windows Server and the SQL Server collation settings. And so, for example, if you have, one time I was working from our office in Israel, and I was connecting to a SQL Server back in the USA. The client that I was working on was set to the Hebrew language, and it used a different collation than what I was used to back in the States. And even though other people had executed the exact same execution, the exact same query as me, SQL Server needed its own execution plan for that other collation and language. Now, once that was in the cache, SQL Server was able to reuse my query, but it had to produce separate ones. And that is also true for a lot of the set options. So there's an asterisk there because I'm not going to spend more time than just talking about it here on this slide. But let's say, for example, you had an ODBC connection string or to a server, and your string, for some reason, had the set ANSI nulls off when they almost always are set ANSI nulls on. And in fact, that's what it is on the server. Then again, we would have to have two different execution plans, one for my unusual set option and another one for all of the other queries that used regular set options. And then finally, SQL Server needs to know about the hardware. After all, it does a lot of parallelizing if it can, and it can't do parallelism unless it knows it has lots of CPUs. In the same way, SQL Server cannot do a great big memory grant for a big, ugly query unless it knows exactly how much memory it has and what kind of sharing it can do across all the different users on the system. And so one of the things that's really interesting about this is that you can actually manipulate this. And so I'm going to show you this in a little demo. What this means for us, though, is that let me pull up there we go. What this means for us is that there are lots of times, and I can't tell you how many times in the past, where I had lots of problems with SQL Server. And the reason why I was having problems is that the code that I was writing was being written on my little desktop workstation, which had 4 CPUs, and it had 8 gigabytes of RAM, and I had a little small version of that SQL Server that I had downloaded to my computer. Well, that doesn't compare at all to the big server that I'm working on that has 2 terabytes of RAM and 512 cores available, and it has a massive multi-terabyte SAN that's running on flash storage that's extremely fast. So what would happen is I'd write some SQL code and it'd work okay here, and then I'd load it up into my production server and it wouldn't work well at all. So one of the things I learned is that we can do this really cool technique called cloning a database. And what this enables us to do is, through a series of short steps I'm about to show you, we can actually take a query that has having a lot of problems in the production server because it's so different in size than our workstation. And we could, for example, have a 300 megabyte version of that 15 terabyte database, but we can make sure that it gives us the exact same execution plans as what we have in production. And that's really, really powerful. So let me show you how to do that. By the way, Jean, are you able to see my screen okay? Everyone, can you see it okay? Okay, I see Thomas is giving me a thumbs up. Thank you, DeFredo. What you need to do in a situation like that, there is a statement called DBCC clone DB. I don't actually use that myself because DBCC clone DB will create that clone adjacent to, on the same instance, the SQL Server basically, as the database you're cloning. And what I want to do is I want to pull that down to my local desktop. So I don't want it to be on the same server. So here's what I do instead, is you go to your SQL Server, and this is just SQL Server 2014 Developer Edition, so nothing fancy here. And you right-click on the database you want to clone, and we have to script out the database, basically. Now, if you were to go to this particular selection option, that makes sense, right? It says script database, but don't do that.
Yeah.
This is not the kind of scripting that you want. Come down instead to... Sorry?
It seems like somebody, sorry about that. It seems like somebody texts me and say they're not able to see your screen.
Oh,
Let
good.
me give everyone access to unmute themselves. if this is repeat to all of them, this way you can stop and reshare again. Just give me
Sure.
one.
If you're able to access the chat or perhaps the Q&A, also let me know if you can see it or not.
Okay. Hello, Dipti. Are you able to see her screen?
Yeah, we can.
Are you able to see his screen?
Yes.
Dipti, you have access to unmute yourself, or whoever is available on the call. Would you mind to let us know if you are able to see?
Yes.
Kevin's screen?
I'm hearing people say yes. Okay.
Yes, we can see it.
Excellent.
Give me a second. Okay, perfect. It seems like someone said yes. Can you please, Kevin?
Are you seeing SQL Server Management Studio?
Okay, perfect.
Let me ask that.
We can see your both SQL Server Management Studio as well as your Teams.
Okay, yeah, sorry about that. Okay, so so let me go on. If you right click here and say
now we see your picture only, not the screen.
Ah, okay, so that is a problem. Let me go back into Teams here. Okay, and share. Okay, so it looks like it got turned off there for a moment. So let me just say share screen. How about now?
Yes.
Yeah, we can see your screen. Yep.
Excellent. Okay, so it's on Management Studio, and I'm on the script O2A clone. So yeah, so if you right click on the database, you'll see that there's an option to script tasks. Don't do that. It's a decoy. Instead, go over here to the tasks selection option. Come down to the option that says generate scripts. Now, I could walk through this from start to finish using the wizard, but it's very fast. So I'm going to save a little time by just flipping over to what it generates. So it will generate a script for you that starts off with a number of files created and all those sorts of things. So in my case, I don't want a 15 terabyte version of that production database. Maybe I just want one that is a few 100 megabytes or maybe a couple gigabytes. So you might want to change the size of the log file, the size and number of the data files. Typically 4 is a great starting place for the number of data files. Then you need to change the settings that appear very closely after the file descriptions. Normally it will say set auto create statistics on. We need to set each of these to off. The reason for that is we are going to be able to actually pull from the production server not just all the schema, all the tables and things like that. We're actually going to pull all of the index and auto-created statistics for all of those objects, as well as the histograms. So that means that SQL Server, the optimizer, will think that this table that only has 500 records in it actually has 500 million records in it, like production, because we're pulling down those statistics and all that metadata. You remember those 3 domain circles? We're actually going to put that into SQL Server, so SQL Server thinks that it has exactly what's in production, even though it doesn't. Okay, so we say set auto create statistics and auto update statistics off because we don't want it to come back at some point and regenerate those and wipe out the production style numbers that we got from the big server. So now let's go and find the next thing I want to show you is it looks like a very normal kind of create database script until you get to a section at the very end here. Well, actually, let me show you in a bit more detail. So we go to tasks, we say generate scripts. And if you've ever generated scripts before in the past, one of the things you've noticed, I'm sure, is that when it creates a let's see here. When it creates a script for you, there's nothing in there about the index statistics or anything like that. So where do we get this secret ingredient? if you scroll down, if you go to the advanced options and then scroll, in my case, I always just look for the first thing that's in boldface, and then I go up a couple steps. So I see here, oh, look at this. There's an option here that says script statistics. And the default is not to script any index statistics. But we have the option to either pull out statistics or, even better, statistics and the index histograms. So that's what we want. And we say, okay, we click next, and we generate the script. Now, what's really cool about that is if you look at the statements here, you will see something that you wouldn't ever otherwise notice, which is you'll have these statements that say update statistics, and then it'll tell you which exactly a given index is. And then you'll also see over to the right this clause that you may not have seen before called stats stream, with stats stream. And then besides that, a very long number, which is a hexadecimal representation of the index statistics and its histograms. So now everything that SQL Server thought was present in production, it thinks is present on your little workstation. So it thinks that the cardinality estimate is 18,000, just like in production. It thinks that the density is, 15. It thinks that the all of these different statistical indicators about how for the query optimizer to process this code is set. So that's in place now. You can also then go a step further. Like in my case, I just wrote a little script to use the good old fashioned BCP command, bulk copy program, to grab out. If I go over here, I say start at record, the first record. That F and L means first and last record. So start at the first record in each table, the oldest record, and give me 50,000 records from each table. Okay. Now, you're certainly aware that this is not going to pass a lot of your foreign key check constraints and things like that. The idea is to simply get some data in here so that we can have a decent test of our different queries. So I built a little version of my database now, and it thinks in terms of statistics that it's just like in production. Now, the next really cool thing we can do, remember the 3 circles we had, the one in the lower left corner was about the hardware, and we can fake SQL Server out with this too. So let's take a look at just a good old-fashioned SQL query, and I'm going to turn on my execution plans here, if I can find it. Actually, I think I had customized this, so I'm going to go over to my options. And I'll turn on the execution plan here. You can also use things like set statistics IO, set statistics time. Those are also very useful as well. And I actually just need to click this button over here. So when I execute this query, it's going to show me the results set, of course, and once it finishes processing, it'll give me the actual execution plan here, okay? And this hopefully is not scary to you. You know how to read it. I did mention I'll take just a moment to explain an execution plan. So typically what I do is I start on the right-hand side and read my way leftward until there is a juncture between 2 different steps. So when we have multiple lines of action and execution plan, start at the lowest one and work your way up, and then read at the next line to where they connect and go from there. So we can see several things. One thing, for example, is each step has a little circle on it with 2 arrows pointing to the left. That means that step is parallelized, okay? Also, you can see that if we reach it all the way to the leftmost step, the select option here, that there's a little triangle with an exclamation point. And so that's telling us that there's a warning that's gone off. And in this case, it is an implicit conversion warning, which can really, really just demolish the performance of your SQL Server. So keep that in mind. Now, we also can see here that the sort operation is 31% of the total cost of this query as well. So this is the kind of thing that can be tuned, right? A sort typically is going to be because of an order by. So possibly you can do sorting on your front end client, and you can just get rid of the order by operation on the select statement itself, and you can save that query a ton of processing power or processing options. But what if we want to pretend now that we are that big server in production? So here we could say something like, what if this particular SQL server had CPUs equal to 64 and memory in megabytes equal to 1 terabyte? Are we going to get a different execution plan? If you did, then that would indicate that there's a really big difference between running this database on a small workstation and a big production SQL server. In the same way, we could actually go the other direction. So one thing that happens commonly is we could, we could buy a great big server and then split it up across dozens and dozens of VMs. And they could be very small in some cases. So we could say, hey, you know what? We'll use this command, DBCC optimizer what if we only had 1 CPU or 2 CPUs and we only had 256 megabytes of RAM. So let me execute that. Completed successfully. Now let's execute that same query. Okay. Have the execution plans turned on so we can see it now. And let's take a look here. Okay, that is an entirely different execution plan. There's a sort, but it happens way over here right after the clustered index scan, not close to the final resolution of the result set. We see there's an index seek, and there is absolutely no parallelism happening anywhere in this query. This setting will stay in effect for this client connection as long as the connection stays active or until you set it back. So let's go ahead and see if SQL Server says something different when it has 2 CPUs instead of just 1. So now let's go ahead and execute this one. Now, again, what we're looking for here is not, we're not looking at the total runtime. We're not looking at latency or anything like that. What we're looking for now are red flags in our execution plans. Okay, so even now that we've bumped up to 2 CPUs, it's still using the old execution plan from when it had just 1, because SQL Server is kind of thinking, okay, I better keep one of those CPUs available for other activities. So I don't want this to parallelize, right? Once you're done, you can come back and say reset all, and it will actually put this back to previous situation where it looks at the actual hardware in terms of memory, RAM, memory, CPUs, and that sort of thing. Okay. So, all right. Now, if you haven't ever seen any execution plans, again, I'm not going to spend a lot of time on it, but just a simple query here where we're going to select sales order ID, sales order header. I got to turn this on. So now our execution plan says, hey, you've got an index seek. You looked at a lot of records. You got 189 records back out of this result set, but we were able to seek to exactly the record that we need and do a range scan forward from there, gave us just what we wanted. Okay. Again, SQL Server and all the relational databases are set-based processors. So when you describe a set, like any number greater than or equal to 283, SQL Server, Oracle, MySQL, they all do a really good job. The execution plan didn't have to change. Here's another thing that only advanced longtime SQL developers know, and many of them don't even know this, is that anytime you ask for not a set, they have a really hard time. Okay, so here I've said, show me all of the sales order IDs that involved a salesperson not equal to 283. Now, intuitively, I would think it's going to have an execution plan that's basically the same, or maybe the inverse of what I asked for with 283, if it equals 283. But when I say when it doesn't equal 283, what are we going to get? We get a big messy, expensive execution plan. And that's really startling to a lot of people. Why does SQL Server or Oracle, why do they do that? Well, as it turns out, in order to find not a set in a relational database, you have to look at every set that exists and throw each of them away in turn until you figure out not that set in your result set. So you can again use some clever developer techniques to get the same results, but you're actually describing sets instead of not a set. So here we say where the value of salesperson ID is not equal to 283, but logically we will get the exact same result set if we say where salesperson ID is greater than 283, that's a set, or it's less than 283, and that's a set. And it is functionally equivalent to the other query. So let's take a look at that result set and execution plan. Okay, got the same number of records, and look at that. Voila, we use that very fast, very direct index seek operation instead of all those other machinations that SQL Server had to do. And this applies for things like if you have correlated subqueries. This query will be very simple, very straightforward. But this one, because it has a not in it, will be very not simple and will take a lot of resources. Okay. So let's move on. One thing I want to show you about, and this is significant for later on. Notice I have this statement here that says DBCC rule off. And I can, whoops, and I can say get to scan. And then I can say DBCC rule on, JN to HS. Well, these are internal nomenclature that the SQL Server engineering team used way behind the scenes, way deep behind the scenes to describe the human readable terms or names in an execution plan. So JN to HS here means join to hash, physical execution of a hash join. Over here, JN to SM, that means we're taking a logical join and turning it into a physical merge join. Okay, so this is again something that's pretty neat, and I want to show you. And it, again, like I said, it does come up later as well. So we could say DBCC, show me all the rules. And it'll actually, oh, you know what? Made a little mistake here. It will actually not show you anything. This is one of the tricky things about DBCC. You won't get any response back from a DBCC statement unless you use DBCC trace on 3604. So you have to execute that string first. And that's kind of like if you're an old time programmer like me, when you said you would enable the console. And so it'd send the output to the screen or to a printer. So that's what this does. Now we come back and execute that again, DBCC show rules. And now we see the results. And here we can see join to nested loop, left outer join to nested loop, left semi join to nested loop, and it goes through all kinds of these internal names that SQL Server has for all the different kinds of optimizer heuristics that it might apply. Okay. Now, like I said, that will be important shortly. If you ever want to really mess with your DBA or make people mad at you at work, you can actually issue commands, DBCC rule off, to turn off one of these optimizer capabilities. So you could say, you know what, turn off join to hash algorithm. I don't want you to do any more hash algorithms for joins. And it will stay off until for the whole server until you come back on and turn it back on. So that is really dangerous. The reason that exists is because back in the very early days of SQL Server, we didn't have other ways to, we didn't have hints, for example, that would say, hey, don't do this algorithm over here. So this was a way you could do testing on old versions of SQL Server where you could say, don't use a hash join because I know you keep defaulting to that because of the size of these two tables, but I want to see and compare the performance for a nested loop and a join. So you could do it with these specific statements, okay? You can also see if any of your rules are also turned off, which hopefully you will have none that are turned off. And in this case, nope. So one of the other things I want to teach you that's also, this is just a sidebar. It's not the main lesson to learn here, but it is pretty neat, is that there is a statement called, DBCC flag called 2588. Now, here's what it does. If you haven't run DBCC trace on 2588, SQL Server continues with default functionality. So when you type in a DBCC statement and put after it a parenthesis and a quote mark and the question mark, it will actually give you all of that particular, if you just do it for DBCC, you'll see all of the different supported DBCC commands there. If you then take a regular DBCC statement and put it within those quotes, when you say DBCC help, what it does here is it gives you even more details about that one specific command. So here we see that there is a lot of different switches that you can apply to the DBCC check Alex statement. Here's what they all are. Okay, that's useful. But if we execute 2588, now when we come back here and say question mark for a list of all the different statements, it also will show you now all the undocumented statements. So right here, if you remember a moment ago, the first one we had was check alloc, but now we've got add instance, audit event, autopilot, buffer, call full text. Wow, what are all these things? And even cooler than that, if we take this statement, this little clause, and we put it within, after the DBCC help statement, and we put it in this particular set of parentheticals, when we execute this, just as before, it'll actually give us all the different switches that can be applied to this. So what autopilot does, just in case you're curious, is that allows us to have a hypothetical index where we could say it's going to be on this table, it's going to have a row count of 40,000 records in it, and so forth. So even though that index doesn't exist, the next time you run a query against that particular table, it might choose to use the hypothetical index that you've created there. It's also important to note that what is accessible using these DBCC statements changes from version to version. So in the older unsupported versions, we have things like DBCC latch. You come up to DBCC 2012. I never did experiment with DBCC crash DB, but if any of you want to do that, let me know how it goes. And so in SQL Server 2014, we had query store added in. So now we have some DBCC commands for query store, and it goes on from there. Okay. But again, there are situations where you might want to say, okay, I don't want to change 300 queries to force them all to try nested loop joins. So what I'm going to do is I'm going to turn off that rule for a while and then rerun my my tests and see if the other algorithms that the physical join algorithms it chooses behave and give me a better set of performance. Okay, so that's a pretty cool set of features. So now you're a part of my secret society, and this is a secret I don't share real often. Now, another thing I want to point out, and this is something I do in a lot of my sessions, is what is SQL Server dealing with when it has to create an execution plan? Well, the SQL Server Optimizer does not try to give you the best execution plan it can. It tries to give you an optimal execution plan. And the difference between optimal and the best, if you were to weigh them on scales, is the best execution plan can only be reached if you have all the time in the world. SQL Server wants to give you an optimal execution plan. And what that means, it's going to have a pretty strict time limit, and it's going to choose just whatever the best plan it found. So when you look at the details in the SQL Server query in the management studio, you'll see very frequently the reason the query terminated was it says good enough plan found. And so let's analyze, what does that mean? In this case, let's take a SQL Server query that has 4 tables that it joins, A, B, C, and D. All 4 tables have lots of columns, but they all have one clustered index, 3 non-clustered indexes. And so the query is going to say, select from the main table A, then join to B on a particular criteria, join to C, join to D. So mathematically, what does this mean? Well, the first thing is that each table, since they're structurally very similar, is going to have about 72 different physical access methods. It'll be able to do unordered clustered index scans. It could do ordered clustered index scans. It could do unordered partial scans, which I have here is, you can see in the middle here, non-clustered seek and a partial index scan plus a lookup. There's lots of permutations it can take, and that's for each table, okay? Then on top of that, SQL Server will look at these different queries that are coming in. And what it wants to do is it wants to minimize the memory grant it has to give you. So one way it can do that is if it rearranges the order of the joins, it may be able to reduce the entire result set very early in the entire process. So if it, for example, joined table D to table A as the very first thing it does, that eliminates 300,000 records from the result set that has a total of 1 million records that it has to process through. On the other hand, if it joins A to B first, it may only eliminate 300 records. Well, if I want a really tight memory grant, I'd be way better off doing the join of D to A first. And so SQL Server will check all of that mathematically and say, oh, okay, this is definitely a better performing option for me. And then finally, there's also all of the different physical join algorithms it might use, the nested loop, the hash join, the merge join. There's also the fact that it may have to do intermediate spills and spools where it has to do some work in tempdb. And after SQL Server does some filtering for redundant work and things like that, what we're actually left with is about 26,000 execution plans for a 4-table join. And so, you know, I'm pretty pleased that SQL Server gives us an answer as rapidly as it does. Here's the thing though, SQL Server says, okay, if I take the time to analyze all these different options, it's going to take a long time. So I'm going to skip all of that and just go with whichever one, even though B does take a lot longer than, you know, you can see there's a difference between A and B. Even if B is the first plan I come to, I'm still going to go ahead and take that one because it's good enough. And so that's how SQL Server does these processes. Now, I mentioned how SQL Server does these different things using the query optimizer. But let's go even a level deeper than the query optimizer. What SQL Server does behind the scenes is it creates something called an internal memo structure. And the internal memo structure it's not really meant to be readable by us normal people. It was developed by the SQL Server engineers for the engineers. But what it does is it actually shows you all of the different things that SQL Server considered doing to execute this particular query. So there have been times when I have manually rewritten a query and used optimizer hints, and I've said, okay, I want you to use a nested loop join on this run, and I'd measure everything. Now I want you to use a merge join, and I'd measure everything. Okay, now I want you to use a hash join, and I'd look at those manually and see if any of those were better. Well, if you know how to read the memo structure, you can see whether SQL Server actually already did that analysis itself. And so that's what I'm going to show you next, okay? So this is the initial internal memo structure. There's also one called the final memo structure, but this is when it first builds the execution plan. Everything here is logical. And remember those strange names like JN to HS? Well, that's what we've got here. Ancillary operation projection list, okay? logical operation get, logical operation select. So this is how it's building out its memo structure. And that's why I showed you that earlier part, because you'll want to experiment around and see what different kinds of things mean. You know, what's the name of that particular step that it's doing in the execution plan. So I even have a script that takes you through a query, changing it and adding more, and it adds a where clause, and then it adds a group by, and then it adds a having, and you can see the new memo structure names for those show up in the list. Okay, so that's the entry number over here on the left. Okay, and this is all logical stuff. So logical is two things about logical. One is it doesn't consider alternatives because there's only one logical way to do things. You only get the analysis of alternatives once you get to the final memo structure that is looking at physical implementations to do the logical thing you've asked it to do. And all of the entry numbers are going to be 0, okay, because it's all logical at this phase. It gives us the name of that logical operation, like a scalar operation aggregate function. So maybe it's doing a group by or something like that. We also have a group reference number here. And these are the child groups that reference the logical operation 13. So what it says is that logical operation 8 and logical operation 9 are then acted upon by operation 12 to give us that the comparison result. So those together all make up this logical operation at group 13. And you can also see throughout that it's giving us cardinality estimates. And again, those are super important, fresh, accurate statistics to making sure that you can find what you need inside of your tables. So the final memo structure is going to be quite a bit more voluminous. It's going to take up more space. So remember in step 13 before, there was that logical operation 8, 9, and 12. But now that we are looking at the physical steps, we can see that it compares two different physical alternatives. One is a merge join algorithm, and the other is a cross apply statement rather than declaring it as a join. In fact, it's using the cross apply as if it was an inner join. And again, we've got the same kind of behavior. Here's that operation we just talked about on the previous slide. Then we also have all the costing that is done here. So this particular step, physical operation restore mapping, remap, has a cost of 20.6. Down here, we see that these two comparative options of the apply versus the merge join, one has a cost of 8.6 and the other has a cost of 8.2. So because 8.2 is lower than 8.6, that's going to be the choice that it will make. And then also, as before, we have things like the cardinality estimates, we have the row goal cost, and so forth. So we can actually look at this at a glance and say, you know what, SQL Server did apply a couple different join algorithms to see which work best for this particular query. And so that is a really, really deep internal that even the most advanced SQL developer doesn't know and doesn't use very often. The thing about it is that it can be very large. So if you have one of these big queries that goes on forever and you're joining 16 tables and stuff, this is, you should never start here. This would be something you do very, at a much later date in the tuning process, okay? So let's move on. Now, one other thing I want to show you is that I also have a number of queries and scripts that give you more information than if you just used an execution plan. So hopefully you've watched the video that I have for top 10 things every SQL developer needs to know, which talks about execution plans, and it talks about how to use set no count, and how to use set statistics time, set statistics IO, profiler, all of those kind of normal things. Well, there's some other things that you can use that are more advanced. And so one would be to use this DMV that not a lot of people have heard of, but this will check to tell us what kind of transformations are happening on my SQL server. And remember the those odd named little heuristics, right? Join to a merge statement, join to a nested loop. This tells us the number of times that it's happened over here on the succeeded, and you can see quite a lot. If we look at this and we scroll down through all of these, we can see there's lots and lots of different kinds of things happening. And so this will help us to determine whether maybe a certain set of queries that are running during a test phase. We could take the and save this result set to a table, for example, and then run our test suite and see how many transformations happen in version A of the tests to version B. And I also have a little script here that you could use in many different situations, but in this case, it's basically selecting from this particular DMV and putting it into a temporary table so that you have a long-running history of these values over time. And so you could say, oh, you know what, we started that test at 3 p.m. and I'd like to know if we started to have a lot more hash joins, because hash joins can be very, very expensive. They always create at least one temp table in TempDB. And, you know, I'm trying to determine if TempDB can handle the load. So you could use this query to kind of aggregate this as we go along. You insert the query that you want to test in between the different code rather than just watching the overall workload. You could tune just 1 or 10 or 20 queries to see which of these different join algorithms it's using. And so it again gives you, some powerful means to tell what is happening in that given set of queries that you're running. Also, I've got some other example scripts for like, what if you want to use X events as opposed to DMVs, or maybe as opposed to perfmon counters. So I've got a bunch of examples of that. And then I've also got some things here that are kind of interesting. Again, not used often, but what this one does, DM exec query optimizer info, you can see down here, it's telling us how many queries in total have gone through the optimization process. Of that total, 64 were trivial plans, 106 made it to phase 1 of the optimization process, phase 0, which is a very simple plan. That means 2 or less tables typically. Search phase 1 means it could have some very minor parallelism, maybe up to 4 tables. And then finally, search phase 0, I don't have any. If we came back, in fact, maybe I'll come back and run that again in a few minutes, okay? All right. Now, I want to show you how to pull those internal memo structures. So again, this content was from a much larger session that I did in the past. And so I went through all the different aspects of the query optimizer and showed how all of those things happen over time. So again, we have to turn on 3604. Otherwise we, won't see the result set, okay? And don't worry, I do have a cheat sheet at the end that talks about all these trace flags, if you like to know about trace flags. And one of the things you can do is you can turn on a trace flag just for a single query. And you do that by using query trace on. So in this case, I mentioned how I start with one very basic query, and I show you the initial memo structure and the final memo structure, okay? So if I execute this one, now what we will see, here's the result set, and in the messages tab, that's where we're gonna see those memo structures. So here we can see that this query just it's basically going to be a trivial plan. It's going to say, I have a logical operation to get. There's 70,132 records in this table, and let's say it has a clustered index. So basically, all I can do is a clustered index scan. That's the only way I can answer this query. If I had a where clause, now SQL Server will look at it and say, oh, maybe there's an index on that column based on the predicate. So again, if we look at this one, it says, no, there's no index there. Only way I can do this is to do a full scan. And so forth. So you can build on this and see what the different operations are that SQL Server retrieves for us or utilizes behind the scenes for us to process this query. So it's getting a little bit more elaborate here. Okay. Now, there's all kinds of other trace flags that I included just because I know some of you are really interested and want to learn more about these things. So trace flags like 9130. And let's see, okay, that's the end of that particular one. Okay. Now, I want to show you the last kind of cool takeaway. Because you attended this session, I'm assuming that you are you're a high-end developer, right? In fact, you know what? I'm not going to show this one in Management Studio. I'm going to show this one in Plan Explorer. So there is a trace flag that is very powerful. Again, I don't recommend that you use this frequently. Use it as kind of your option of last resort. What this does, in effect, is give the optimizer more time to find a good plan or a better plan. Now, just because you use this trace flag, it doesn't mean you'll get other plans. And it doesn't mean that if you do get another plan, it will be a better plan, right? And definitely don't tell Microsoft that I taught you this technique if you have to call for support, because they ain't cool with that. This is an undocumented, setting here. All right, let me close these windows for a sec. But one more time. All right, and that is not working. I'm going to have to break out for a second to pull up Plan Explorer. Now, Plan Explorer is our free tool, and I like to remind people that it's so free. We don't even ask for an email address. You're not going to get spammed. You know, you're not going to have people calling you up in the middle of the night trying to sell you anything. And we actually initially built Plan Explorer for ourselves. Oh my goodness, it looks like I may not have it installed here. There we go. We built this for ourselves in our support team. And as people would call to get support, we would get so much positive feedback from our customers that they would say, you helped me fix this problem because you had an internal tool? Well, can I have that internal tool? So we started to make it available for them. All right, let's see here. I thought I would be able to find my execution plan here, but it looks like I am having some problems. Maybe that's it. Okay. So one of the things you'll notice about Plan Explorer, first of all, is here's our query. And across the top, we have a number of different kinds of indicators about the query. And these are all kind of those red flags that I was mentioning to you earlier, things like an implicit conversion or a spill or spool warning. So here, one that normally would take you 2 steps if you were using Management Studio, you'd have to run it first with an estimated execution plan and then second with an actual execution plan. It's showing us that the actual versus estimated rows retrieved by this query is greater than 10%. And that means your index statistics are bad, okay? So we have a key lookup, that's also bad. We have a situation where we're missing index statistics entirely. We have a sort operation, again, not good because those sorts spill into tempDB. Now, if you look at the execution plan down here as well, it looks quite a bit different than what we would see in Management Studio because of things like the line thickness. We have color coding when there's certain problems. So we can hover over these and see what the problems are. We can see there's an issue over here with the implicit conversion. There's a little bang mark here saying that this sort is spilling to a second level spill to TempDB. So very informative stuff. And in fact, one of the things I like about this is on a right click, you know, I've tuned thousands of SQL servers in my career, and the Management Studio default for what each of these costs are calculated are based on a combination of CPU plus IO. However, of those thousands of SQL servers I've tuned, about 90% of them maybe get as busy as 40% on CPU. It's IO that's the problem. So we can even go in here and say, you know what? I don't want you to use the Management Studio default for costing of CPU plus IO. I just want IO. And so what happens there is we see that there's a new part over here on the right, the clustered index scan, that is more expensive than if we just did it by the Management Studio default. Again, I'm just barely scratching the surface on what this tool can do, but it's some really cool stuff. And we can do some things like, let's see here. Maybe it's under view. Well, we can do a live query replay on this. And another thing that's pretty neat is if you do your work here in the SQL Plan Explorer rather than Management Studio, is it'll actually keep a version history of all the different versions that you've run. And for this particular query, when I use the execution plan trace flag 8780, if I can find it again, where did it go? There we go. If I used 8780, it'll actually show you all the differences in the execution plan, and you can see at a glance, hey, this took 16 seconds less to run than it did with the default execution plan. And so maybe I'm going to use a plan guide and force SQL Server to use this alternative plan now, because I do know and I have tested that it works better. Okay. So with that, we're running out of time. There are a couple other slides that explain some of the scripts that I showed you. And you don't really need all of this information. You know, we didn't show all of these different specific sets of queries to show us what these different execution options were, but it's some good stuff. And so I encourage you to come back and take a look at this and analyze it later, maybe add it to your collection of knowledge about SQL Server tuning. Now, I mentioned a lot of trace flags, so I promised that I'd give you all of the trace flags at the wrap up. I'm not going to spend time on them, just know that those lists are there. Also, some of the query statements, DBCC statements, and DMVs that I used. Again, not a lot of has gone into explaining what these are, so they can be really helpful if you're doing some high-end work there. And so, actually, with that, I'm just going to go ahead and wrap it up here. What sort of questions, Jean, do we have in the queue that I can answer?
By the way, thank you so much, Kevin, for your session. I learned so much. There were one question Anders asked. Anders, would you mind to unmute yourself and then talk to Kevin? Are you there, Anders?
Sorry, I don't really have a mic on this. I don't think I really asked a question, but.
So you said something about the index, correct?
Oh, no, that was just a statement, not a question.
Sure. Um,
knows how to find me, so
Yeah.
we could take this discussion
I've seen a
offline
lot of
too.
weird stuff. Maybe not as much weird stuff as Kevin, but I've seen a lot of weird stuff.
You have definitely seen some weird stuff.
Nomi, would you please unmute yourself and answer your question? It seems like Nomi is not available now. Uday, if I'm saying it right, can you please unmute yourself?
Trying to get the slides up here.
Yes. To
Somebody
be
asked-
honest with you, you did a great job. I think that could be the reason why nobody want to ask any question. That was amazing work.
So again, like I said, folks, I'm always happy to discuss this with you further. So if you're a little bit shy and didn't want to discuss it publicly, then I'm on Twitter, Facebook, LinkedIn, all of those places at KE Kline. On email at kekline@outlook if you want to reach my personal email, or you can reach me at kevin.kline@solarwinds.com. And I know my employers would be annoyed with me if I don't share that we have, products, things like here's the link to Plan Explorer. We have several other free tools. I have a lot of other webinars that you can watch, centuryone.com/webinars. So I'd love for you to take advantage of those free resources, and also love to give you a demo of our products. If you are a user, as Anders is, I thank you, and my children thank you, because you're you're keeping a roof over my head. So I'm thrilled that you're one of our customers.
You are very welcome, Kevin. There is one question that said, can they apply the same thing on Azure?
Yes. Yeah, these in general work on SQL Server on VMs, on an Azure VM, on SQL Azure DB, SQL Azure Managed Instance. I haven't tested every single one, but in general, these trace flags will, particularly the ones on the internal memo structure and the one that says give the optimizer more time, those definitely do work there. Well, everyone, thank you so much for your time. I've got other sessions, other meetings I have to run to, so I'm going to go ahead and jump out. But again, thank you so much.
Yep, I'm about to share my screen now, if you don't mind, Kevin. So this way I can end the session.
Did you want to give away an ebook or two?
That would be great. Please email me this information and also the slide deck plus the script, and I will share it with the script with the group.
So we have 45 names in the list here, and yes, Jean, I will follow up as you requested. So what I'm going to do is get my old D&D dice out here, and I'm going to roll and then count and see where we get here in terms of winners, right? All right, so 1, 2, 3, 4, 5, 6, 7. John Repass, are you with me, John?
John?
Winner, chicken dinner. Thank you.
That's right. John, if you will follow up and send me an email, kevin.kline@solarwinds.com, then what I'll do is I'll get you in touch with O'Reilly, and we'll get a copy of that ebook into your hand. All right, and let's do one more.
I'm sorry, what was the email? I'm sorry, one more time.
I will share it with you.
Okay, great.
Great, thank you. Okay, and so the next winner is Hovek Melkomian. Are you with me, Hovek?
I'm here.
Yay! Well, the book is still like $45 or $50 on O'Reilly's bookstore, so that's a nice little giveaway. If one day when COVID is not with us, I'll be able to give you a signed copy. But for now, we'll just stick with the ebook.
Would be my honor.
Yes. Can you guys text me your email and I will share Kevin information with you so this way you guys can follow up.
Sure. What do you need, Gene? I'm sorry.
Just all I need is your email. Yeah, just text me your email or on LinkedIn, find me on LinkedIn, just text me your email and I will be happy to share it, share the information. So this way you guys can follow up with Kevin.
Sure, Kevin. If you could just show your email address one more time.
Yeah, I actually just dropped it into the chat, and
Okay, perfect.
I may be still sharing my screen, so you might be able to see it there.
I think I'm sharing it.
Okay,
No,
all right, perfect.
Kevin.
Well, folks, thank you so much for your time. I really appreciate it. I know you've got a lot of competition for your time, so the attention means a lot. And I hope to see you at another session again soon. Thank you, everyone.
Thank you so much, Kevin. I hope to have you next year. And thank you all for attending this webinar. Don't forget to register for our next webinar and see you next week. Have a wonderful weekend, guys. Take care. Bye.
Bye.